All right, today we're going to look at direct variation. Direct variation is just described as an equation that's in the form y is equal to kx. So it's going to look like this every time. X and y are still values for an ordered pair, okay? And we know k is not equal to 0. All right, so k is just referring to the constant of variation. Bless you. K is also going to be the slope of the line. All right? So, when we talk about slope or constant of variation, where could you always find that value? In front of what? In front of x, every time, okay? So, on today's lesson, if it asks you for the constant of variation, all you have to do is look at your equation for the value in front of x. Same thing if it asks you for slope. Look at the value in front of x. So what are you going to know if it asks you to name both things? Will they be the same number? Yes, because constant of variation and your slope are exactly the same, okay? Now, if you want to open your book, I'm going to be looking at a couple graphs, so it might be helpful for you to see these in your book on page 185. Now, on some of this, honestly, it gives you a graph. You don't even necessarily need the graph to answer the question, okay? Because on number 11, it asks you to name the constant of variation for each equation, then find the slope of the line that passes through each pair of points, okay? So, somebody tell me, on number 11, what's the equation that it gives you? Okay, so what would be my constant of variation in this equation? -5. Okay, what's going to be the slope also of this equation? Now, am I going to ask you to take those 2 points and use y2 minus y1 over x2 minus x1? No, because what value are you going to get when you do that? -5, right? Because when you have two ordered pairs and you do y2 minus y1 over x2 minus x1 to find slope, isn't that what we just stated here? And if slope is the same as the constant of variation, right, we don't need to do that extra work. If you know what the value is for k, then you know both of those things, okay? All right, what about on 13? What's my equation for 13? Okay, so what would be the constant of variation? -1 over 5. What would also be the slope? -1 over 5. Okay, should you put those in parentheses? No, because they're not an ordered pair. You're just stating two values. Okay, that's going to be the easiest thing you do on your assignment today. Yes? Okay, any questions on that? Do we understand that the constant variation and slope are the exact same thing? Yes? Okay. All right, let's talk about graphing. Okay, we're going to graph y is equal to -7x. We're going to make a table. Now, can you choose any x values that you want? Yes. What would be the three easiest ones? -1, 0, and 1. Okay? So, how do I solve then? How do I know what my y values would be? You plug it in. What is -1 times -7? +7. What's -7 times 0? And -7 times 1? Okay? Oop. right? So all I have to go do is graph those three ordered pairs. So at -1, I have +7. I have 0, 0, and at +1, I have -7. Okay? Now, that's all it asks you to do. I'm just asking you this because it's something that we've talked about. What's the slope of this line? -7, right? Always the value in front of x. How can I tell that it's negative just by looking at the graph? Because it's going down, okay? Just like we took our quiz over the other day. Okay, let's look at y is equal to 7/6 x. Okay, now I have a fraction, so think about what number could you multiply by that fraction that would get rid of your fraction? 6. So wouldn't it make sense to use 6 and -6? Yes. What other value should I always use in the middle? 0. Okay. Now I'm going to write the first one out just so you can see it. If I multiply 7/6 times -6, that would be -6/1, right? What happens to the 6's? They cancel, and you would just get
Calling auto warranty services. To opt out from.
okay, positive or -7?
Negative.
Hold up. Okay. All right. 0 we shouldn't have to worry about because anything times 0 is just 0. Okay. And then +6, it's going to do the same thing. So when I plug in +6, what would that give me for my y value? +7. Okay. Is everybody okay with that? So a lot of times people see a fraction and they think, well, this is going to be really difficult. Not when you only have to plug in one value for x, just choose whatever the denominator is. It'll cancel out the denominator and just leave you with what's on top. Okay, so when I plot those points, I go -6 and -7, 0, 0, +6, +7. Sorry, I know my line's not very good. I'm trying to. Okay, what's my slope of this line? Okay, how do we feel about those graphs? Every single time, you're just going to make a table, choose 3 values, plug them in, and graph. Okay? Any questions? Okay, we're going to solve if y is equal to 22 when x is equal to 8. We want to find y when x equals -16. Okay? Now, what's the equation I gave you at the very beginning of class today for direct variation? Okay? So, the first thing it gives you is what you're going to use. What do you think you're going to plug in for y and x? 22 and 8. Okay? So, y is 22, x is 8. So what are you solving for first? K. How would I get k by itself? All right, I would leave it as so we know k is still slope, so you don't want to change it to a mixed number, so you can leave it as an improper fraction, just write it in simplest form. What would it be?
11/4.
All right, so our slope is 11/4. So that's the first thing that we found, but that's not even what it asks us to solve for. What does it ask us to solve for? it wants us to find y when x is equal to negative 16. So how would I do that? Can I plug in two things to this equation? Abby?
Would you do, y equals 11/4 times 1/16?
Perfect. I'm going to put negative 16 over 1 since we have a fraction, right? 4 and 16 simplify, so all you're doing is 11 times negative 4, so my value for y would be negative 44. Okay, so basically you're going to take the x and y value it gives you, solve for k, and then use that value for k to solve for your missing value. Okay, we're going to do another one. Let's do if y is equal to 12 when x equals 6/7, we want to find x when y is equal to 16. Okay, anybody want to try this one? All right, Leah, go for it.
So first we do 12 equals 6/7. And you could divide or multiply that by the reciprocal.
Good.
So I get 12 times 7/6.
What can I simplify on the left side?
Yeah, 12 is like,
Okay, so what value would I get for k?
14/1.
Perfect, or just 14, yeah. All right, so I found my value for k. Now can I find the value for x when y is equal to 16? So again, you're using this equation every time. Now what does it give you that you can plug in, Leah? What would I set that equal to? Good. So remember, once you've used this part the first time, you don't need it anymore, okay? Because now we're trying to work with this. All right, and all you'd have to do to get x by itself, so x would be equal to 8/7. Okay. All right, we're gonna do one more, and I think you're probably okay with it. Let's do if y is equal to 15 when x is 3/4. Find x when y is 25. Okay, somebody else want to try this one? All right, Nate, go for it.
So we do 15 equals k times 4.
Okay.
Then multiply by 43.
So we know everything on the right side cancels. You're left with k. What about on the left side?
Simplify 15 and 3 to 1 and 5.
So k would be equal to
20.
20. All right.
And then y equals k, so 15, wait, 25 equals 20 times x.
Good.
And divide by 20.
So x would be equal to
5/4.
perfect. Okay. All right, how do we feel about this? Not too bad. Anybody have questions on any of it that we did today? All right.